Assalamualaikum and good day everyone. Today we will learn on chapter 4, life annuities. So as an introduction, life annuities is a series of payments made continuously or at equal intervals such as monthly, quarterly or years or annually while a given life survives. For example, for pension plan, for EPF, we got a lump sum of money, so the participant can buy an annuity to change it from the lump sum amount to income stream, so a regular series of payment. As long as that individual survive, they will receive benefits or the payment. So the NSP or net single premium, or we call it as actual present value of the annuity payments, have two types. First is continuous and discrete. So for continuous, the T is a future lifetime of X, and for discrete, K is the notation for the future lifetime of X. So the PDF for continuous GT is TPX mu X plus T, same as for life insurance, as well as for discrete case. So GK, the PDF is KPX QX plus K, or we can write down in terms of this conditional probability. So the definition: Y is the present value random variable of all payments to be made under the annuity if X dies at time T. So the expected value of Y, the present value, is equal to the net single premium or the APF of the annuities. So first we will look at the first annuity, whole life annuity. So we have two types of whole life annuities, whether it is continuous case or discrete case. So for continuous, RM1 per annum or annually payable continuously to X while X survive. Okay, so life insurance versus life annuities. So life insurance benefit will be paid when an individual dies. However, for life annuity, the benefit will be paid as long as the individual survive. So that's the difference between life insurance and life annuity. So for discrete case, we have two types, annuity due and annuity immediate. So for annuity due, the payment will be made at the beginning of each year for annual case. However, for annuity immediate, the payment will be made at the end of each year when the individual survive. So we look at the first one, the continuous type. So when we draw the timeline, so X plus T is the age of death or time of death. So the payment will be made until an individual die. We look at how we derive the NSP. So Y is the present value random variable. So recall in business math, we learn on the present value where the formula is 1 minus VT over I or delta for the force of interest. So VT is 1 plus I negative T for interest case, or for force of interest we use E negative delta T. So in annuity, it comes from the present value random variable. To find the expected value for Y, so we have to integrate. Like life insurance, we have two components here. So the present value components and the GT or the PDF. So this is for present value and this is for PDF. We can write down in terms of TPX times mu x plus T. So in investment, we do not consider the probability of survive. So for insurance, we have to take into account the probability of survive and force of mortality. And then mu x plus T, when we write down in terms of TPX, is actually the negative differentiate of TPX over TPX. So this one you can refer in chapter 1. Then we simplify the equation and finally we get VT times TPX dt for annuity, whole life annuity. So AX, this referring to the continuous, we have bar, so X for current age, and we don't have N since it is whole life. So for whole life, the upper bound is infinity from 0. So EY is equal to expected value of the present value. So then we get this equation. So finally, the relationship between annuity and insurance is this equation. So from life insurance, we also can get life annuity. If life insurance here is whole life, so then here also for whole life annuity. And then we also can find variance. So variance for Y is this one in life insurance. So then we can use this equation, the relationship between annuity and insurance, and we get this one. As a summary of whole life annuity, so if we look at one by one, ZT is BT times V the power of T. So BT we assume as 1 ringgit, that's why we have VT here. So for whole life annuity, we have the benefit if the death happened before N or the death happened after N, we still get the benefit. It can happen at any times. So the expected value of ZT is insurance. So the variance is this one. And the Y is present value. And the expected of present value, we get annuity for whole life. And this is for variance to find the whole life. Now we can look at example 1. Find annuity, continuous annuity at age 20, assuming first de Moivre's law with omega equal to 60 and delta equal to 0.05. And second one, we have to use constant force of mortality with mu equal to delta equal to 0.05. For both case 1 and 2, find the probability that the present value is greater than annuity. What does it mean by this equation? It means that the insurance company have sufficient fund to pay to the annuitants. So the present value can cater the annuity. So for the first one, de Moivre's law, we can find the life insurance to find the life annuity using this equation. So this equation is very important. So we can find the whole life insurance. So for de Moivre's law, the upper bound is omega minus x, and this is Vt, and this is TPX mu x plus t. For de Moivre's law is 1 over omega minus x. Then we substitute the values inside the equation, and then we solve for the integration. We got 0.4323. This is whole life insurance. So then to find the whole life annuity, we substitute in this equation and we get 11.3534. So it's easier for us to calculate life insurance than life annuity, because life annuity we have to integrate VT-TPX only. So for life insurance we have mu x plus t as well. So we can cancel out and make it simpler. So usually to integrate the VT-TPX, we have to use integration by parts. For life insurance case, just can cancel out because we have the mu x plus t component. And then now we can find for constant force case. So this is for Vt, and this is TPX mu x plus t. So I put the constant in front. So since the mu is constant, so mu x plus t is equal to mu, and the TPX is equal to E negative mu t. And then we substitute the values inside, and the mu is equal to 0.05, and the delta also equal to 0.05 according to the question. And then we solve for the integration. So for constant force case, the upper bound still infinity, and then we substitute inside. So for the infinity we got 0, and then the answer is 0.5. So then we substitute into the annuities using this relationship, and we got 10 for the annuity at age 20 using constant force. So for constant force case, alternatively, we can find the life insurance using this one. So finally we get AX is equal to mu over mu plus delta, since the mu is constant. So then we substitute into the life annuities, and then we get for annuities for constant force is equal to 1 over mu plus delta, and for insurance for constant force is equal to mu over mu plus delta. Therefore, when we want to find the annuities, for that case, we still get the same answer like the first method. And this method is much easier. And for the case of the present value much greater than annuities, now we look at the first case for the Moivre's law. So using the Moivre's law, the annuity is equal to 11.3534. So we just take 11.35 and then we substitute inside here and we solve for this equation inside the bracket to find the T. So we want to find how many years the insurance company have to make sure the fund is sufficient to pay to the annuitants. And then we solve for this equation. So this one we change the notation since we put the negative at the right hand side, and we solve for the ln to get the T, and then we get T much greater than 16.76. So this symbol is for P, surviving. So greater sign for probability of survive. So meaning that T is equal to 16.76, P 20, because the current age is at 20. And then we find 16.76 P 20. This is when we use survivor notation, Sx plus T over Sx. As I recall, for the Moivre's law, the TPX is equal to omega minus x minus T over omega minus x from this derivation. And then we can substitute to find the TPX for this case, and we get 0.581. So the probability of survive from age 20 to age 36.76 is 0.581 in order to make sure the insurance company have sufficient fund. So the next case for constant force, so A20 is equal to 10. So we substitute 10 here, and we want to find the T, same as the Moivre's law, and then we solve for this equation in the bracket using the ln to find the T, and finally we get T is equal to 13.86. So same as the de Moivre's law. So greater signs referring to the probability of survive. So for constant force, the TPX is equal to E negative mu T. And then we substitute the mu inside and the T as well, and we get 0.5. So it means that from age 20 to 30.86, where T equal to 13.86, the probability of survive is equal to 0.5.